In this video, I'm going to be talking about how to use fundamental identities, trigonometric identities, to help simplify some expressions that involve sines, cosines, and tangents. The first problem we're going to look at is one that looks like this. And so what we're going to try to do is take this complicated equation that involves sines and cosines and even cosines squared, and we're going to try to simplify that down and see if maybe there's an easier way to write it, a simpler way to write it. So I'm going to start off by taking a look at this. I'm going to look for common terms. It's commonly going to involve factoring. And if I take a look at this, I notice that both of these terms, both the first and the second, have a sine of x in them. So I'm going to start off by pulling that sine of x out in front. And if I factor out sine of x, then I will be left with cosine squared x for the first term and a minus 1 for the second term. Now this is important. If I see cosine squared of x minus 1, then I need to pull back on the original trig identities that I'm working with. The Pythagorean identities is what they're called. One of those identities says that sine squared x plus cosine squared x is equal to 1. And I see a 1 and I see a cosine squared. And in fact, anytime I see squared, I should probably think of this first. Okay? So I want to try to rearrange this. Can I rearrange this so I can get a cosine squared minus 1 out of it? And it turns out I can. If I subtract 1 from both sides, then I would be left with sine squared x plus cosine squared x minus 1 is equal to 0. And so to get this by itself, I'm going to go ahead and take the sine squared x and I'm going to move it over. And you can see then from this that cosine squared x minus 1 is the same thing as negative sine squared x. And so really then, that means what I have is this. Where I had this before, this cosine squared x minus 1, I'm going to go ahead and replace that with a negative sine squared x. So I have really sine of x times negative sine squared x. And just like anything, whenever you take x times x squared, if I take sine times sine squared, I end up with sine cubed. Of course, I should probably worry about the sine first. As an SIGN, I have a positive value times a negative value. That's going to give me a negative value in the end. Sine times sine squared is sine cubed. And I'm not affecting the angle. X stands for the angle involved. And I'm not doing anything with that. I'm not cubing the angle. It's not x cubed or anything. The angle stays the same. All I'm doing is I'm cubing the sine after I figure out exactly what that is. And so it turns out then, this is a much simpler way of writing the same thing as sine x cosine squared x minus sine x. Agreed? Let's do the second example over here on the right. I'm going to do the same thing. So I look at these terms and I say, look at that. I've got a cosecant in both of those. So let's go ahead and pull that out first. Let's factor it out. I end up with cosecant x, and if I factor that out, I'm left with cosine squared x minus 1. And I'm not going to repeat the process. I would go through the same thing. I see a square, so I need to refer back to my Pythagorean identities. It turns out it's this one here. And if I rearrange just like I did that, that's negative sine squared. So I have cosecant of x times negative sine squared x. And normally I would go through the work and I would show all this, but since we just did it over here on the left side, I'm going to go ahead and skip it for now. Alright, so the idea is this. Does that simplify any further? And in order to know the answer to that, I would have to know what cosecant really is. So off to the side, I'm going to figure out, let's see, cosecant of x. That's a reciprocal identity. Cosecant is the reciprocal of 1 over sine. Right? So I'm going to go ahead, and since this is sine, and since that's sine squared, I'm going to go ahead and put these all together. I'm going to replace cosecant x with 1 over sine x. 1 over sine of x times a negative sine squared x. And what I end up with is this. I can combine those into one fraction. The sine squared goes on the top, the negative sine squared. So it's really the same thing as this. And just like if you had x squared over x, how those powers of x would divide out, I can do the same thing here. So I'm going to take sine squared divided by sine, and I end up with just a negative, because of the negative sign, sine of x. And so those two problems here that involve simplifying, and most of the time it's going to involve factoring, that's a good start to working with the fundamental trig identities.